Hello, my name is Sergio Morello. I'm a student at Liberty University, and today in this video we are gonna talk about engineering economies and then permutations and combinations in manufacturing process. First of all, let's start with engineering economy. The first thing that we have to do is differentiate between a single payment and equal payment series. Over here we have the formulas for those. We can see here the single payment. The single payment, you're gonna have either an amount of money in the present or in the future, and you wanna know how much is gonna be worth that amount of money in the present or in the future. So if you have the present amount of money, you wanna find out the future, how much is gonna be worth in the future. Then if you have the future amount of money and you wanna find out how much is worth that amount of money now in the present. However, the main difference between this single payment and then equal payment series is that in equal payment series we're also gonna have the amount of money either in the present or in the future, but we wanna find out how much is that worthy making different payments throughout a determined period of time. So here we're gonna have, for example, for this one compound amount, we're given A. This is different payments throughout a determined period of time, maybe 20 years. We're making single payments during every month, and we want to find out how much is going to be worth all those payments in the future. For example, the present worth is the same thing. We're gonna make uh, we, we wanna know how much all those payments that we're gonna do throughout a determined period of time, how much all those payments are worth in the present. So once we've done that, now let's get more into details. Let's go to PostgreSQL, and I'm gonna show you guys what I've done. Alright, so over here in SQL script we can see the formulas that we saw before previously in the PDF. The formulas for single payments and compound and equally payment series. So let's get started with single payments. What we're gonna do is create two views, one for the future worth and another one for present worth. What we do is select all these columns from tables that we already have with different values, and then we're gonna put this formula over here to calculate the present worth of all the information that we have. We're gonna do the same thing for present worth. We select the columns that we want from the table where we have all the data, and then with the formula we wanna calculate the present value for those for that data. Now with another SQL script we're gonna do the same thing for the formulas of equally payment series. Over here we're gonna see the present worth, and we do the same thing. We select the columns that we want, that have all the information that we want to calculate the present worth, and over here we can see the formula. If we compare the formulas that we saw in the PDF with the ones that we have here, is exactly the same. Now we're gonna do another view on here for equally payment series. We're gonna have four views, one for present worth, another one for future worth, another one for sinking fund with the formula and everything, and another one for capital recovery. So once we've done that, let's go ahead and start with the views. Let's start with single payments. We're gonna go single payment, the present worth. So well, we can see here the formula and find P given F. This was given, this is the future, this is a value given, this is the number of periods, probably 10 months, the interest rate, and then this is the calculated present worth for this amount in the future. And we do the same thing with all this data. Now we're gonna go ahead and see the single payment for the future worth. Now instead of having given the future, Now the given is the present, so we're gonna find the future given the present value. The present value is here $3,000 given a number of periods, so probably 20 months, 20 years, it doesn't matter. And then we have here the interest rate and the calculated future value for that amount of money. Now let's go ahead and get started with equal payment series. We're gonna go to compound amount, which is the future worth. We can see here, for example, if we wanna buy a house, we wanna find out the future value given A. Well, we know we're gonna have to make different payments, which are gonna be $800 a month during probably this 180 months with a 2% compound monthly, and this is gonna be the future value of the house, $1,372,833.25. Then a value for a Ferrari, I'm gonna pay $400 every month during probably 10 years with a 3% interest rate and compound monthly, and this is gonna be the future value of the Ferrari, $449,477.83. The same with the Rolex, and we can do this with whatever we want to find out. Now we can go to sinking fund. What we want to see here is find out A given F. We know the future value and we want to find out this amount in the future. Well, how many payments we're gonna have to do to get to that amount in the future. So this amount is given at the end, $60,000 to buy a boat, and we have 60 months with 1% compounding monthly, and we're gonna have to make $734 payments every month. Now we can go over here and see the present worth. Same thing, we wanna buy a laptop. We wanna find out the present worth given the payments that we're gonna make. We're gonna make probably $150 every month as a payment during 1 year, 12 months, with the interest rate is gonna be 1% compound monthly, and then the present worth of the laptop is gonna be $1,688. We can do the same thing with a car, a machine, whatever we want. And now, right after this, let's go to another way, capital recovery, which is right here. And this is just, I'm gonna invest some money and I wanna find out how much I'm gonna get back. So find A given P. I have an amount of money, I invest that, and I wanna find out how much money I'm gonna get back monthly, or it can be also seen as a loan. So we have the present value is $5,000 during 24 months, percentage compound monthly, which is 1%, and then the capital recovery. So the amount that I'm gonna get every month, or that I'm gonna have to pay every month, is gonna be $235 for this amount in the present. Now let's go ahead and see the uniform gradient series. What it does is, for a factor G, which is this one, 200, so I'm gonna have this factor every month, and then the month 1 is gonna be just 200, the month 2 is gonna be 200 times 2, month 3 is gonna be 200 times 3. And what this does is, we want to find out A given G. We want to find out the payment that I'm gonna do monthly. So according to this G and this 12 months and the interest rate compound monthly, which is 1%, the amount A is gonna be $1,076.29. Alright, now what we want to talk is about combinations and permutations. As you guys can see here, the formula for combinations is factorial of little n divided by factorial of small n times factorial of big N minus n. Then permutations is factorial of n divided by factorial of big N minus n. What it does in combinations, the order doesn't matter. In permutations, the order does matter. Therefore, the permutations is always gonna be bigger than the combinations. And now let's go ahead and see the application for manufacturing and for the manufacturing process. So we could use combination of permutations to detect defective samples in a production line. This is one example. We could be saying, okay, we want to have the quality control. We want to control the quality of a production line, and we want to detect the defective products in any production line, in any industry, in cars, phones, computers, everything. So this is the example. A production line of 40 cars, 3 of those are defective, and then we're gonna have a simple random sample of 4 cars. How many samples are we gonna have? Well, this is just a combination of 40 choose 4. How many of those samples will contain exactly one defective car? What we're gonna have to do is, okay, and I have 4 samples. Out of those 4, 1 is only gonna be defective, the other 3 are not gonna be defective. So we just do a combination 3 choose 1 times combination 37 choose 3 divided by the combination 40 choose 4. And then we can also see how many of those samples will contain at least one defective car, the same process as the previous question. And then finally, what is the probability that the random sample will contain exactly one defective car? So we can just run this code, and we can see over here the samples that will contain exactly one defective car is 25%. Then the samples that will contain more than one defective car is 72.27%, and then the probability that random sample will contain exactly one defective car is gonna be 2.7 to the 10 to the 6. So thank you so much, and hope this is helpful. Thank you.